under root 2 is irrational. What is an irrational number? An irrational number is that cannot be written in the form of P over Q. We cannot write it as a numerator over a denominator. It is a non-repeating, non-terminating decimal. In this case here, we have to show that root under root 2 is irrational. So let us assume that under root 2 is rational. We are going to assume the contrary. We need to prove under root 2 is irrational. We will assume that under root 2 is rational. Now, if under root 2 is rational, that means we can write under root 2 as a over b. So we'll write under root 2 in the form of a over b, because we assumed it is rational, where b is not equal to 0. A and b are co-prime numbers. Co-prime numbers means they do not have a common factor. Now this expression we are going to square. So we square on both the sides. This is by squaring. Under root 2 into under root 2 is 2. This will be a square over b square. So 2b square equal to a square. That means our a square equal to 2 into b square. So we can say that 2 is a factor of a square. And if 2 is a factor of a square, 2 is also factor of a. Because remember, if I have 12 equal to 3 into 4, which means 3 is the factor of 12 and 4 is also the factor of 12. In this case, we have a square equal to 2 into b square. So 2 is a factor of a square and b square is also the factor of a square. If 2 is a factor of a, so I can write my a as equal to 2 into some other number, say c, where c is an integer. This was our equation 1. Now in our equation 1, which was 2b square equal to a square, I am going to put the value of a. And here I have found the value of a. I took a as 2c. So for a, I am going to put 2c the whole square. So 2b square equal to 2c the whole square. So 2b square equal to 4c square. If I divide the equation by 2, I'll get b square equal to 2c square. Now again here I can say that 2 is factor of b square. So 2 is also factor of b. Now look at the statements very carefully. 2 is a factor of a and 2 is a factor of b. So 2 is a common factor of a and b. A common factor of a and b. So are a and b co-prime? No, a and b are not co-prime. If a and b have to be co-prime, they must not have a common factor. So I can say a, b are not co-prime because they have a common factor 2. But however, right in the beginning, look here what we said. We said a and b are co-prime, means we said that a and b do not have a common factor. And now we have come to a result that a and b have a common factor. So there is a contradiction. But we know a and b are co-prime. So why is there a contradiction? Because the assumption was wrong. We assumed that under root 2 was rational. It has to be irrational. Now this contradiction has arisen because of our incorrect assumption. And what was our incorrect assumption? That under root 2 is rational. Therefore, we can say that under root 2 is not rational. Under root 2 must be irrational. Because if we take under root 2 as rational, we come to this contradiction. We get this contradiction. So therefore, we say that root 2 must be irrational. So our assumption was incorrect. That assumption that root 2 was rational was incorrect. Let's go to the second one. Let's prove that under root 3 is irrational. To prove under root 3 is irrational, we start assuming that under root 3 is rational. We assume the contrary. If it is to prove it's irrational, let us assume that it is rational. Here we assume under root 3 as rational. And if it is rational, therefore, this under root 3 can be written as under root 3 in the form of a over b, because it is rational, where b is not equal to 0, a and b are co-prime. Now what you mean by co-prime? They have no common factor. Now this expression under root 3 equal to a into b, we are going to square. On squaring, we will get under root into under root, that is 3 equal to a square over b square. So we have 3b square equal to a square, which means now a square has got two factors. One is 3 and the other one is b square. So I can say now that 3 is factor of a square. So 3 is also factor by theorem of a. If 3 is a factor of a, so a can be written as 3 into another number. It's a factor into c, where c is an integer, any integer. So in this equation 1, we'll take up equation 1, which says a square equal to 3b square. In that I'm going to substitute this value, a equal to 3c. So for a I will put 3c, and this is the whole square, which is equal to 3b square. That is 9c square equal to 3b square. I divide the whole equation by 3, so I get 3c square equal to b square. I divide by 3. Now look at this expression, b square equal to 3c square, which means b square has got the factor 3. So I can write now 3 is factor of b square and 3 is also factor of b. So 3 is a factor of a and 3 is also a factor of b. Let me write that up. 3 is factor of a and 3 also is factor of b. So can I say a and b are co-prime? Definitely not. A and b are not co-prime. But we had assumed in the beginning it was given to us that a and b are co-prime. Why do we say a and b are not co-prime? Because a, b have common factor, and that is 3. But this contradicts the fact that a and b are co-prime. That a and b are co-prime. That's what we started in the beginning. Why did we get this contradiction? We got this contradiction because our assumption was incorrect. This contradiction has arisen because of our assumption that, what was the assumption? We had taken that in the beginning, that under root 3 is rational. This assumption was wrong. So now we can say that therefore under root 3 must be irrational. Show that 5 minus under root 3 is irrational. So just like that earlier, let us assume that 5 minus under root 3 is rational. Now if it is rational, we can write 5 minus under root 3 as a over b, where a and b are integers and a, b is not equal to 0, a, b are coprime. So now I have 5 minus under root 3 equal to a over b. Now I'm just going to rearrange and I get 5 minus a over b equal to root 3. Now if you look up here on the left hand side, my left hand side, this is my left hand side. It's made up of 5, which is an integer, a is an integer, b is an integer. So this all are integers. So my left hand side is rational. So I can say 5 minus a over b is rational. So under root 3 should also be rational. But we know under root 3 is not rational. This contradicts the fact that under root 3 is irrational. We know under root 3 is irrational. Why did we come across this contradiction? Because our assumption was wrong. Hence we can say that our assumption that 5 minus under root 3 is rational is wrong. 5 minus under root 3 must be irrational. So this contradiction has arisen because our assumption is wrong. And you know what was our assumption? Our assumption was that 5 minus under root 3 is rational. That is wrong. So we can say 5 minus under root 3 must be irrational. For the next, prove that 3 under root 2 is irrational. So we do the same thing. Let us assume that 3 under root 2 is rational. So if 3 under root 2 is rational, we can write we can write 3 under root 2 in the form of a over b, where b not equal to 0, a and b are coprime. So we have 3 under root 2 equal to a over b. Just we need to rearrange. So under root 2 equal to a over 3b. Now look up at the right side, the right hand side. The right hand side is a over 3b. A is rational, it's an integer. 3 is also rational and b is also rational. Therefore a over 3b is rational. And we know that a over 3b equal to root 2. So therefore I can say that root 2 is also rational. But this is not true. We know that root 2 is irrational. So this contradicts the fact that root 2 is irrational. So why did we arise at this contradiction? It's because our assumption was wrong. So this contradiction arises because our assumption is wrong. And what was our assumption? That 3 root 2 is rational. This was our assumption, that 3 under root 2 is irrational. This assumption is wrong. So I can say 3 under root 2 is irrational. So let's get on to the exercise 1.3. Prove under root 5 is irrational. So to start, let us assume that under root 5 is rational. Hence, we can write under root 5 as a over b, b not equal to 0, and a, b co-prime. So we have under root 5 equal to a over b, and if we square, we get 5 equal to a square over b square. So 5b square equal to a square. In the next part, we can say 5 is factor of a square. 5 is factor of a. 5 is a factor of a. A can be written as 5 into c, where c is any integer. Now we go to this equation 1. Here in equation 1, we know 5b square equal to a square. Here we will put the value of a square. We know the value of a is 5c. So here we will put 5c the whole square. So this is going to become 5b square equal to 25c square. We divide the equation by 5, so we get b square equal to 5c square. Now again here I can say 5 is factor of b square, which means 5 is factor of b. If 5 is a factor of b, we can say that b can be written as 5 say into d. So here I have an important point. 5 is a factor of b, 5 is a factor of a. So 5 factor of a, 5 also factor of b. So a and b are not co-prime because they have a common factor. And common factor 5. So this is a contradiction because we started saying that a and b are co-prime. This contradicts the fact that a, b are co-prime. And why did we get this contradiction? This contradiction has arisen because our assumption is wrong. Our assumption that root 5 is rational, that's the assumption we took right in the beginning. Root 5 is rational, is wrong. So we can now say if root 5 is rational is wrong, so root 5 is irrational. Proof 3 plus 2 under root 5 is irrational. So we assume 3 plus 2 under root 5 is rational. And if it is rational, hence we write 3 plus 2 under root 5 equal to a over b, b not equal to 0, a and b co-prime. So 3 plus 2 under root 5 equal to a over b. On rearranging, we get 2 under root 5 equal to a over b minus 3. So 2 under root 5 equal, take the LCM here, a minus 3b over b. So root 5 equal to a minus 3b over 2b. Now we take up the right hand side. This is our right hand side. Is a minus 3b over 2b. Here all the numbers are rational. A is an integer, it's rational. 3b also integer and rational. And 2b is integer, so also rational. Which means a minus 3b over 2b is rational. But we know that a minus 3b over 2b is equal to under root 5. So we can say under root 5 is also rational. Is also rational. This is a contradiction. Under root 5 is not rational. Under root 5 is irrational. But this contradicts the fact that under root 5 is irrational. Hence we can say, we conclude that 3 plus 2 root 5 is irrational. Prove 1 over under root 2 is irrational. So assume 1 over under root 2 is rational. And if it is rational, we can write 1 under root 2 as a over b, where b not equal to 0 and a, b are co-prime. So we have 1 over under root 2 equal to a over b. On squaring, we have 1 over 2 equal to a square over b square. So the b square equal to 2a square, cross multiplying. So now here I can say that 2 is a factor of b square. So 2 is factor of b. If 2 is factor of b, we can write b as 2 into c, where c is an integer. Now we start with this first equation here, first one, where it was given to us b square equal to 2a square. Wherever there is b, I am going to write now 2c, because I know b equal to 2c. So 2c the whole square equal to 2a square. So 4c square equal to 2a square. Taking 2 common out, we can say that 2c square equal to a square. Now here 2 is factor of a square. So 2 will be a factor of a. 2 is factor of a. So we have now 2 is a factor of a, and here we have 2 is a factor of b. 2 is factor of b. So a and b have a common factor. So we can say a, b are not co-prime. This is a contradiction, because we said in the beginning that a, b are co-prime. This contradicts the fact that a, b are co-prime. Right in the beginning, here we said a, b are co-prime, and now we're getting a result that a, b are not co-prime, because they have a common factor. Now we got this contradiction. This contradiction has arisen because our assumption is wrong. What was the assumption? Our assumption 1 over root 2 is rational is wrong. So if it is wrong, that means we can say hence 1 over root 2 is irrational. Next, we need to prove that 7 root 5 is irrational. Let's assume the contrary. Let us assume that 7 under root 5 is rational. And if it is irrational, we can write 7 under root 5 as a over b. All rational numbers can be written as a over b, where b not equal to 0, a and b co-prime. So if 7 under root 5 equal to a over b, now on squaring on both the sides, we have to square in this place, we can just rearrange. So root 5 equal to a over 7b. Now look up at the right hand side. The right hand side is a over 7b. A is a rational number. It is an integer. It's rational. 7 we know is definitely rational. And b is also rational. So the entire right hand side, which is a over 7b, is rational. But a over 7b equal to under root 5. So now we can say that under root 5 is also rational. Is also rational because they are equal. But this contradicts the fact that under root 5 is irrational. We know under root 5 is irrational. And hence, why did we get this contradiction? Because our assumption is wrong. Hence, we can say 7 under root 5 is not rational. 7 under root 5 is irrational. Here our assumption was wrong. All this problem, this contradiction happened because assumption is wrong. What was the assumption? Assumption is wrong, that 7 under root 5 is rational. It must be irrational. Prove that 6 plus under root 2 is irrational. So first we assume just the opposite. Assume 6 plus under root 2 is rational. Now if it is rational, we can write it as 6 plus under root 2 equal to a over b, b not equal to 0, a, b co-prime. So let's get back now. So we have 6 plus under root 2 equal to a over b. So under root 2 is a over b minus 6 on rearranging. So the right hand side, which is a over b minus root 6, will be rational because a is rational, b is also rational, and 6 is also rational. So the right hand side, a over b minus 6, is rational. But a minus 6 over root b is under root 2. So we can say that under root 2 is also rational because it is equal. The right hand side is equal to the left hand side. But this contradicts the fact that root 2 is irrational. We can prove that under root 2 is irrational. Now this contradiction has arisen because the assumption was wrong. Assumption that 6 plus under root 2 is rational is wrong. So if it is not rational, we can say 6 plus under root 2 is irrational.